Okay, finally we can begin to look at solving systems of equations. So we are going to see how this the method called the Gaussian elimination is used to solve systems. Okay, now let's consider the following system. So we have three equations and three unknowns. So we're going to solve for x1, x2, and x3 here. All right. Now we can write this system in terms of matrices. So we can write it as this matrix times that times this. Okay. You can verify that when you do the multiplications here, you get these systems. Okay. This is why all this time we have been looking at matrices and their properties. It is because once we have systems of equations, then we can always write them in terms of matrices. Okay. Now we can also write this as these matrices. So this is the matrix A, and this vector is the matrix X, and the right hand side of our system is this vector B. Okay. Now if we pre-multiply both sides by the inverse of A, this is what we get. And when we simplify, we get the identity here, because we have seen that if you multiply the inverse by A, if we multiply A times its inverse, then we get the identity. Okay. And we also know that if we multiply the identity times a vector x, we get only x. Okay. And so the x that we are looking for here is simply pre-multiplying b by the inverse of a. Okay. But this is not how we solve systems in practice. We actually have better ways, more efficient ways, which do not involve finding the inverse. This is what I will be illustrating in this chapter. Okay. Now let us consider again that system. So the first thing that we do is to write the augmented system. The augmented system is basically taking this part of the system and putting it here. We also combine with the right hand side, which we put here. Okay, so if you look up the word augment in the dictionary, it simply means to increase. All right. I wouldn't be quite sure if it makes sense here, but in a way we have increased this part. Okay. Okay. Now we are going to proceed by using what are called row operations. Now row operations take the following forms. Okay. So these three are all valid row operations. The first one is we can interchange equations. So as you may expect, if you interchange equations, the solutions won't change, right? That is the case. We can also multiply an equation by some number, right? That would not change its solution, right? We can also add a multiple of one equation to another. That again will not change the solution of the equation. Okay, so only these three are permitted as valid row operations. Now let us see a few here through this example. Now we're looking again at that augmented system. We are going to change row 2 to row 2 minus 2 times row 1. We're also going to change row 3 to row 3, the original, minus row 1. Okay, so as you can see, these two operations are all valid row operations. Okay, the effect of them will be the following. Now we have said that row 2 is going to be row 2 minus 2 times row 1. This means this part will be 2 minus 2 times 1, which is 0. This part is 3 minus 2 times 1, which is 1. This part will be 1 minus 2 times 1, that's minus 1. This part will be 9 minus 2 times 4, that's 9 minus 8, which is 1. Right? In the third row, we're going to lose this, which means that our new row 3 is going to be row 3 minus row 1. Okay, so in this case we have 1 minus 1, that's 0, minus 1 minus 1, that's minus 2, minus 1 minus 1, that's minus 2, and finally we have minus 2 minus 4, that's minus 6. Okay, so this would be our stage 1. We can go to stage 2. In stage 2, we are now going to do this operation again, another valid row operation. Okay, so we're going to change our row 3 here to row 3 plus 2 times row 1. Okay, so in this case the first one would be minus 2 plus 2 times 1, that's 0. The next will be minus 2 plus 2 times minus 1, that's minus 4. And the last number here would be minus 6 plus 2 times 1, that would be minus 4. Okay, the effect of this is that we want to get zeros below, right? Zeros below this number. We have them zeros. Also below 1 we want this 0. You will see that this makes the finding the solution easier, as this slide is showing. Okay, so now we have this the final form of the augmented form, which is also referred to as the row echelon form. Okay, so in this form, if we introduce back our x's, we find that the last row implies this. Okay, this is what we have. As you can see, this would multiply x1, this would multiply x2, this would multiply x3, and this would be the right hand side. Okay, but because these are zeros, we only have minus 4 here times x3 equal to minus 1. Now if we simplify and find x3 here, that means we divide by minus 4 both sides here. The last equation we'll get 1. So, and from row 2 it means x2 is going to be 1 plus x3, but because x3 is 1, we now have 1 plus 1, which is 2 for x2. Finally, x1 is equal to 4 minus x2 minus x3, which is going to be 4 minus 2 minus 1, which is equal to 1. Okay, this is what we refer to as backward substitution. Okay, this is because we start from the back and work our way towards finding x1. So we, in other words, we first find x3 and then find x2 and then finally find x1. Okay, that is where the word is coming from. Okay, all right, so before I proceed, maybe I can pause the video so that we start on to something new in the next segment.